So this topic is called finding the roots of a quadratic equation of the form ax squared plus bx equals 0. So if it's of the form ax squared plus bx equals 0, that variable, whatever they have in there, will be able to be factored out. So before we do anything, we're going to factor a y and actually a 3 also, because 3 can go into itself and 12. So if we factor out a 3y, we're left with y plus 4 equals 0. Because of the zero product property, one or both of these needs to be equal to 0 in order for this equation to be true. So we set each term equal to 0, and then we solve for the variable. So in the first case, y has to be 0 in order for 3y to equal 0. In the second case, if we subtract 4 from both sides, y has to equal -4 in order for that to be true, for that factor to be equal to 0, and then the whole product will be 0. So y is equal to 0 and -4. Notice that when we factored them, because there was a y all by itself without a plus or minus sign, it's just multiplied by the 3, then y equals 0. And then the y plus 4, we did the opposite sign. So it was a -4. Because you get to the point where you can here, okay, so let's put them on the same side. So 4y squared, we always want to have 0 on the right, or equal to 0. So we're going to factor out, again, a 4y. So we already know y is going to equal 0, y minus 6. Because y minus 6 is there, we know y has to equal 6. If y equals 6, then 6 minus 6 is 0, and 0 times 4, doesn't matter what y is, will give you 0. So our answers are 0 and +6. Okay, let's do one more. Let's get, again, we'll do u squared minus 18u, factor out a u, so we know that u will end up equaling 0, and then we have u equals 18, will give us a 0 there. So we have 0 and +18. That's the end of the lesson.